Hello everyone. This is the video I mentioned in the lecture that I'm going to make and explain to you how to do the voltage conversion when you're changing among different kinds of reference electrodes. Okay, so today I'm going to talk about three different situations. The first one is if you know the voltage of a half cell versus SHE, what is the voltage versus silver chloride? Okay. The second case is if we know the voltage using silver chloride as a reference, then what is the voltage if we use SHE? And the last one is to convert silver chloride to SCE, which is the saturated calomel electrode. Okay. Before we start, there are a few things that we would like to clarify on. First of all, what does it mean by saying some voltage versus SHE or the voltage versus silver chloride? We know that the cell potential in this case is defined as um, the the half cell electrode, the half cell reaction of interest subtract by the reference electrode. Okay, so when we say 0.328 volt versus SHE, it means that the voltage of A minus SHE is 0.328 volts, okay? And then it was asking for what is the voltage if we use silver chloride as a reference electrode. So what we're looking for is actually whatever the voltage for A is and subtracted by silver chloride, what is the voltage? Okay, so basically you're using different references and you're trying to calculate when you're using different references, what is the voltage? Okay, now one thing, the information we already know is actually SHE is defined as 0 volt, okay, because that's the universal standard. We just assume SHE to be 0 volt. And we say that silver chloride has a known fixed potential of 0.197 volt. It is actually using SHE as reference, okay? This is 0.197 volt. Right? Which means that silver chloride subtract by silver chloride subtract by SHE is 0.197 volts. And we know SHE is 0. So we can say that silver chloride is just defined as 197 volts, 0.197 volt, okay? And same thing for the SCE. The SCE, I believe, is 21241. So SCE can be defined as 0.241 volts. Okay, so here we're using two absolute value, but keep in mind those absolute value are using SHE as the reference because SHE is 0. So you just assume that silver chloride equals to 0.197 and SCE equals to 0.241 volt. Okay, and now let's go to the question number 1. Okay, now because A versus SHE is 0.2328, right? So we know that A minus SHE is 0, it's 0.2328 volts, which means that you can say that A is 328 volts using SHE as a reference, right? Now, we want to look for what is A minus silver chloride, which should be straightforward because your A is 328 volts and your silver chloride, as we said here, is 0.197. So you just minus 0.197 volts. And you can get 0.131 volts, right? So that means this is, sorry, the question mark here is 0.131 volt versus silver chloride. Okay, so that's for A. Now, for B, what we know here is B versus silver chloride is negative 0.213 volts. But we want to look for B versus SHE, right? So we're looking for B minus SHE. And we know SHE is 0, so we're looking for B, okay? And what do we know here is this is negative 0. This is what we're looking for, okay? Now, what do we know here is B versus silver chloride, right? So B minus silver chloride is negative 0.213 volts. And we do know that silver chloride is 0.197 volts. So B will be negative 0.213 volt plus 0.197 volts, right? You just do the calculation, which will give you 0.016 volts, right? That's the situation the second situation. Okay. Now the third situation is we know the voltage versus silver chloride, but we want to calculate the voltage versus SCE. Okay, how do we do that? So what we know here is C minus silver chloride is 0.05 volts. Okay. Now we want to look for C minus SCE, right? As we mentioned earlier, when you're trying to calculate the voltage versus the reference electrode, you're just subtracting the potential of that reference electrode, okay? We don't know, so C minus SCE, if we want to calculate that, we have to first calculate C, right? Because silver chloride is 0.197, so based on this, C will be 0.050 volt plus 0.197 volt, which will be 0.247 volts, right? And what we are actually calculating here is versus SHE, right? It is, SHE is 0. So the absolute value you're looking for here is just, you can be considered as versus SHE. Now, when you want to calculate SCE, you need to bring in SCE potential, right? So this will be 0.247 volt subtract SCE, which is 0.241 volt. So at the end, you have 0.006 volt, okay? So now you can see that when you're trying to convert from silver chloride to SCE, what you're doing is actually you're calculating 0.050. That's the difference versus silver chloride. You first add the silver chloride up to it, and then subtract by this is the silver chloride. This is the SCE, right? And by doing that, you will get the same thing. So 0.050 plus 0.197, you get 0.247, and subtract by this, you get 0.006. Okay. So this is what the three examples I'm giving you. Now, if you want to apply those calculations to universal situation, okay, like without giving you an actual number, and let's say we want to calculate a universal case, like whenever a value is given with SHE, can we calculate the value versus silver chloride? We can do that, right? So here's the thing. If you want to convert any value versus SHE to any value versus silver chloride, what do? You subtract 0.197, okay? But if you convert silver chloride to versus SHE, you will plus the value. You will add 0.197 to whatever the value you have, okay? Now, if you're converting silver chloride to SCE, you will have to add 197 and then subtract 0.14241 volts, okay? So that's how you do it. I know I didn't cover the cases for SCE, the saturated calomel electrode, but you can apply the same rule to SCE, but you just replace silver chloride with SCE. So the two values will be changed here. And if you're converting from SCE to silver chloride, then you also have to flip these two values, okay? I try to leave you some space to think about it by yourself. But if you have more questions, please feel free to email me.